So,
Are you going to use the fit chart?
yeah. I don't know where to put it. I was thinking to put it.
No, that's okay. No, I can.
That's
That's
probably.
totally fine.
Cool. So, I'm gonna talk today about DDD, but not the real DDD, about Delusion Driven Development, and why you shouldn't do it. First, I'm going to introduce myself briefly. Well, I'm Felipe Fernandez. I work at Software Craftsmanship for Codurance, for those guys. As well, Pedro is working with us. I'm currently working in a client called Crowdmix, really cool place. We didn't release yet, but try to remember the name. I think it's going to be something really big. I sometimes blog in the Codurance blog, so you can read the stuff there. And less often, I write some stuff in my handle Twitter, Felipe Fernandez. So let's start defining what is delusion. So this is the Wikipedia definition, a little bit complicated, but the summary is what is involved. It's a belief that is contradicted by reality, and as well, it's a symptom of mental disorder. Maybe a little bit strong. I don't want to talk about that. I want to talk about mental disorder. But I like that word because, well, because it's used in pop culture. I don't know if you know, there's a book called Delusion by Richard Dawkins, and it's trying to show how some kind of beliefs that are based on incomplete information or are based in simply not having good faith are really dangerous for whatever you are doing. So I'm gonna try to show different delusions in our industry and showing how painful and poison are for us. So, yes, I told you I'm going to go through a couple of delusions, but the blocks of those delusions are going to be pretty much operations, testing, and design. Let's start with operations. Well, first, I want to say that I want to talk operations from a developer perspective. I'm a developer, I'm not a sysadmin, but I'm going to talk not how to keep our system up and running, but what is the infrastructure that developers we have to create in order to keep those systems up and ready. I don't know how many of you are working in this kind of DevOps environment, but I would say that even if you don't or you are not interested because it's not related with your development, I would say this is something that is coming to stay because modern world with math and web services and stuff like this is forcing us to go into that direction. So, well, what I'm trying to say is that if you are not interested, try to listen because it's quite cool. So, first one, I'll have a loop whenever it's needed. That's the first delusion. As you can see, this little girl is trying to embrace that attitude. No? Let's jump and wherever I go to the floor, I will think on it. So, my diagnosis of why we do that, why we think in this kind of delusion is, or because we are overconfident in our skills, or just because we are lazy. It could be a mix of both. It's just easy to think in the happy path scenarios. We are usually overwhelmed by the pressure of business. We have to deliver features, and then, well, let's think only on the happy path scenarios. The problem of that is that I think that most of us know that the cost of addressing those problems in the future are quite high. So I'm going to provide an example of this kind of I'll have a look whenever it's needed. That is diagnosis in distributed environments. I'm going to close the door. Yeah. Like that. So, diagnosis in distributed environments. First, what is diagnosis? Well, diagnosis is what you have to do when your tests are not enough. We are a software craftsmanship community, so we believe in tested code, but we are humans as well, so sometimes the tests are just simply not enough. Whenever that happens, what you need to do is go into your system and query the state of it to see what is the data that it puts your system in a buggy condition. So we have different methodologies to do that diagnosis. most typical that we do is debugging, querying the data store that our application has or logging. That's quite easy if you do it in a non-cluster synchronous monolith with a single data store. So I'm going to explain it. Well, how could you probably do it? So let's say that you have a single application server that is not clustered, it's only a single monolith and is going into, let's say, Oracle, something simple. So how do you debug this? Well, if you have a IntelliJ or whatever debugger that you're using, it's quite easy to put some breakpoints in the code, that's okay. How do you query the data store? Well, probably is if it's your only single data store, Oracle or whatever, you already master the client that you are using, you already know how to do queries, you already know how to inspect the state that is inside of this. And how can you read the logs? Well, it's quite easy. It's a single service, single server, so this stuff is going to be in a single file. It's quite easy. You go there and you read what is going on. But when you spoiler, when you go to when you go to distributed diagnosis methodologies, well, the stuff changes a lot. So first, the debugging, well, log. I mean, it's almost impossible. Let's say that instead of having this simple monolith, you have 3 services, and all of them are clustered, replicated in a farm, something like this. And for making the stuff even complex, let's say that inside of these components you are using asynchronous programming, promises, futures, code, or whatever you want. So debuggers, probably they are not going to work. It's something that you need to forget. Usually they are not a good idea because, well, attaching a debugger in production is never a good idea, and sometimes you can't replicate that data that puts your system in a buggy condition in your local. So that's cool. Querying data stores. What's the problem? Sometimes you have fragmentation. Let's say that this service is storing stuff in Cassandra, but this one is doing something in Elasticsearch, and this one is doing something in Kafka. That means that you need to master the clients of all of them. And as well, you need to know how easy or, well, what are the limits of queries of those systems. I can talk about my real experience. If you decide to put the stuff here in Kafka or whatever message engine, and you decide to put it in binary, for instance, it's going to be almost impossible to query that, because it's binary. And then, yeah, you can have a client that is going to parse that into some schema, but what happens if you put something that is not following that schema? You're going to get in problems. So the stuff gets a little bit complicated. With logging, it's directly madness if you don't think as soon as possible on what it means logging in distributed environment. Why? Well, first, because you are not going to have a single file that you can query easily. You are going to have 1, 2, 3, 4, 5, or you are going to have 9 or an explosion of different places that you can have a look on the logs. So the first step in order to fight against that is that you need some kind of centralized logging. You need some guy that is going to be grabbing those files and aggregating it in a single store. As well, you have, as I told before, you have the synchronicity problem. So you need to have some kind of tracing mechanism to know, okay, see, if my system is starting here and it's finishing here, I want to know 1, 2, 3, 4. I need to know how the story was. So I need some kind of correlation ID, and I need somehow to know that this correlation ID was, well, the correlation ID has some kind of attribute that is going to tell you that this happened before the other one. That's complicated, and it's something that you should do as soon as possible. Why? Because it's not as easy as going there and, okay, I'm going to log something different right now. No, you need to change every single protocol of your components. You could communicate through HTTP, so then you need to include that correlation ID on the headers, but then you could communicate through Kafka or whatever. So it's a massive amount of job. It's not something simple that you can do like in the beginning. So, yeah, I'll have a look whenever it's needed. Please don't. It could be really hard and you want to be prepared. That's my conclusion with this example. Next one, you already saw the picture. A little bit of spoiler. I need to remove that application now. Well, I don't know if no pun indented or maybe yes, but I think that you get the point. So, yeah, duplicate duplication hurts if you care about your code. I mean, most of the people, whenever they start thinking on refactoring design patterns and stuff like this, they always think in drag. Don't repeat yourself. Oh my God, I'm seeing some duplication in there. I'm a clever developer. I'm going to try to generalize that. I'm going to try to remove that duplication as soon as possible. But the problem is if you address that prematurely, that is going to cause pain. So I want to provide an example, again, of that. So let's say that you have a deployment pipeline that is kind of customized by yourself. Okay, you could use Drone.io, you could use, well, there is a lot of platform as a service that allows you to do a continuous deployment pipeline quite out of the box. But let's say that you want to create your own scripts in order to have some control over them. And in this context, I'm going to talk about, let's say that you have a microservices, right? So, well, the problem is if you go for that kind of generalization too early, is that you are going to have problems in the future. I'm going to say three steps that are usually happening in a continuous pipeline deployment. Versioning, checking, and continuous integration. So, versioning, whenever you deploy a new component in your graph of dependencies, obviously you want to increase the version. No? So the problem that I found in the past is that in our project we were using the first 3 components of our microservice architecture were based on Gradle and were based on some kind of submodules, right? We assumed that every single component was using Cassandra, so we need some submodule for migrations, another one for keeping the application, blah, blah, blah. So then we took a decision that it was doing scripts that are following that assumption. So the scripts are expecting that you are going to have some kind of Gradle properties file in some submodule of a Gradle property, multi-module project. That's a problem because if in the future you want to use SVT, you want to use another structure that is not nested, that is a single project, your scripts are going to fail. And it's kind of the backbone of your continuous deployment, so it's going to be quite hard to refactor that. Another step is checking. So whenever you deploy something, you want to double check that that stuff is really working. So it's not as easy as, boom, I'm going to deploy something into my environment and that's okay. No, I need to check that stuff. Our assumption was that everything is going to be a HTTP service, right? So I'm going to provide a health check endpoint in there, and I want to know that that is ready. But what happened if in the future you decide to use, I don't know, a scheduler or something that is not exposed in an HTTP endpoint? Then your scripts are going to fail because they are expecting that you are publishing something in export with that endpoint. So that's an assumption that is going to cause you problems in the future. And continuous integration as well. There are different needs for different components. Not every single component needs system test. Not every single component needs that you deploy anything for running the test. So don't do that in the beginning of your company, of your project or whatever. Do it whenever it's stable. Because that's something that it was really cool. The other day I read Twitter has a engineer effectiveness project or division. And what they are trying to do is trying to cut this kind of fragmentation. No? So they have Scala projects with a build system, they have Java projects with another build system, and their conclusion is that it's cool to have that in the beginning, and then whenever you are really grow, and then you are stable, and then you really know what are your needs, then boom, cut the stuff and try to generalize. But do it then, not in the beginning, because otherwise it's going to be quite hard to refactor it in the future. Next one. I guess that is ready. So what's the relation with this picture? Well, this is the face that the people usually put whenever they say this. I guess that is ready. Yeah. So the example is a walking skeleton. So how many of you know about the concept of walking skeleton? So the concept of walking skeleton is that before starting delivering your features, what you want to do is trying to deliver the thinnest slice of your application, but end-to-end. So doing that, you can know if the design that you have for your system is testable, if it makes sense from deployment point of view, etc., etc. The problem, if you don't have that DevOps mindset, is that maybe you could think that that walking skeleton ends in your application code, and that's not true. So you could have, let's provide an example, you could have a drop wizard application that is with a system test that is up and running, is doing a hello world, everything is fine, is connecting to your data store, to Cassandra, but then what happened with your infrastructure? What happened with the provisioning if you are deploying the stuff in Heroku on Amazon Web Services? And what happened with your continuous deployment pipeline? That component is fit nicely with those or not. So the idea is not starting in the system test. It's not, well, it's not starting in the application code. It's really starting in the DevOps part of the application. If you don't have that skill, that's okay. Try to do some kind of cross-functional team so that you can have help of the operation guys. But start from that, because otherwise you have a false sense of security, a false sense of, okay, yeah, the story is ready, but then, boom, let's try to deploy it. Oh, no, the structure is not fit with the stuff that we need. Or, whoa, what the fuck? What happened with the scripts for deploying, for provisioning stuff in Amazon Web Services? I don't know, that's not my job, it's operation. No, that's not your, I mean, that's not the point. The point is not doing your job, it's trying to follow this in the end. Address your non-functional challenges as soon as possible, and following this philosophy. This is a growing object-oriented software guided by test book, that is amazing. And the philosophy of that book is that you should do that, this kind of walking skeleton as soon as possible. Because otherwise, you are going to incorporate technical debt because you have that false sense of security. Okay, that's ready. Business is happy. Okay, there's the things of the sprint. Let's move into the next future. No, let's do it as soon as possible because otherwise, it's not going to be done. It's going to go into the backlog of the technical debt. So I guess that is ready. My advice is don't guess, double check. Testing. The parts are working, so the whole. Okay, as you can see, probably those guys tested it properly, this kind of boot. It seems that it's not going to break if you put some pressure on it, but they didn't test the bridge as a whole. That's quite a problem when you have a distributed system. You could have confidence on your parts. Okay, this component is working pretty much okay, but when you have a distributed system, the integration is full of problems, of caveats, of, well, as some colleague of mine said, the devil is in the integration, these kind of systems. So that means that you need to have a different approach of testing. Unit test is not enough. That doesn't mean that you need to give up on unit testing. If you try to integrate tests, if you try to small test or whatever is your approach for testing distributed systems with a unit test, it's not going to work. I mean, the combinatorial explosion of those is going to be massive. Well, it has a lot of trade-offs. But the point is that it's not enough. So you need to have another kind of approaches. So you just need another approaches in order to succeed when you have a distributed application. For instance, contract testing. That's something really cool about thinking in your APIs like they are going to be published, like they are going to be libraries. Because sometimes we just think, okay, that's that public method. Well, who cares? Who is the consumer? Myself. I'm going to write the consumer as well. It's more or less I can understand it. But no, that doesn't work when you work in a distributed environment, because probably you're going to have different teams. You are not going to have a compiler that is going to tell you, okay, that API is changing. So the breaking changes of the API, you need to think more on it. Let's say that this is the conclusion of this. There's a really cool talk of Joshua Bloch, the guy that wrote Effective Java, and he's one of the designers of Java API, so he knows a lot about API design, and he's trying to encourage that kind of mindset. Let's try to design your APIs like if you are designing it to public, with the same care that if you would design in core Java API. Another stuff is the smoke testing. Just in case if you don't know or you don't share my definition of the smoke test. The smoke test is something that hits your system like a black box. So the point is that you deploy something first, and then you have a test that is providing an input, and you do some state checking testing in the end to see what is the output. but you don't have any control. You can't get mocks. So the point is just seeing more or less how your system is going to perform in production. So in fact, you could run a smoke test in production if you do it with thinking a little bit on it. As I explained you before, if you don't have this kind of centralized logging or correlation IDs, the smoke tests are not enough because you are going to have a red in your team city in your continuous integration server, and then you are not going to have any clue of what was the problem. So if you want to test your distributed system, you need as well to test some tiny infrastructure before. So the parts are working, so the whole, my advice is that don't underestimate the complexity of distributed system. Next one. Testing is always good, okay? Well, that's, you can see this little lady is trying to test the gun. It's cool, but not always is good, no? So let's try to go to the point. So most of the developers that does programming love testing, and that's cool. That's cool. We want to sleep well. We want to have confidence in our test. We want to know that our system is working as it should. But the problem is that if you are not aware of the trade-offs of every approach, most of you know the pyramid of testing, right? Here you have unit test, and you have whatever, acceptance test, UI test. So that pyramid is talking about the cost of testing. So if the cost of testing are bigger, they should be on the top of this pyramid. So those tests are useful, but they are going to cost. So the point is that, okay, testing is good, but you need to know what are the trade-offs of them. So I'm going to provide three examples. Well, this micro unit test is, well, it's because, not everybody agrees what it means, a unit test. Some people think that a unit test is something that is attached with a class, with a function, with a component, with a behavior, well, whatever. What is true is that if you have tests that are really, really attached to your implementation, they're going to give you a lot, but as well they are going to be brittle. So that means that whenever you change your production code, the test is going to fail. And that's something that you have to take in mind. I mean, it's not the end of the world, but it's a trade-off. So let's think on it. The maintainability of your code is going to be harder. A slow test. If you need to connect to network, to database, to, well, whatever that is outside of your process, your tests are going to be slow. And that's something that you could manage if that's not too slow. But if you have a test suite that is taking 1 hour, that's even worse, or something that not having tests. Because the developers are going to lose the confidence on those test suite. It's like, I don't know, it's going to take 1 hour, so the people is going to start having fear of integrating because they don't run the test before, because who is going to run a test suite that is taking 1 hour? Right? And then, hard to read and write tests. This is an example that, imagine that you have some acceptance test, and instead of deciding writing it in a business language, you decide to do it in a front-end language. So you decide to include the payloads of your contracts. So you decide to include the JSON. So this is an acceptance test that is expecting this JSON and is going to be returning this JSON. That has a lot of values, but they are really hard to read and write. So then you need to think if those trade-offs are enough or not for you. But in the end, trade-offs are just trade-offs. So I just showed you three examples of when those guys are a little bit painful, but obviously unit testing gives you pressure on your design, gives you the fake localization, so if something fails, you really know where it's failing. The other way around, you are going to have just like a cluster of objects. I don't know who is the guy that is failing right now. And it forces you as well to have this kind of baby step mindset that is really cool. A slow test sometimes are just needed. I mean, if you are going to integrate with Cassandra or whatever, you need to know that your client is working. You just can't assume that, well, I don't know, because it's a client that is in GitHub and it has 300 of stars, I assume that it's going to work. No, maybe not. You need to test it. So slow tests are there. Hard to read write tests. Yeah, I explained before, including JSON like a bad thing, but not necessarily. That could enforce communication between front-end developers and back-end developers. So sometimes it's, well, it's a pay that you can afford to pay. It's a price that you can afford to pay. So the delusion of testing is always good. Well, as long as you understand the trade-offs, yes, but they are not a silver bullet. And the last block, design. So, well, I think that all of us agree that design is the key of maintainable systems. But as Sandro explained before with the inflection point talk, it's hard to know when you are over-engineering, when you are thinking too much in the future or too less. It's hard to find that sweet spot that is, okay, that's the moment, right, that I'm okay. So what I'm going to try to show with a couple of delusions is how we should think on it, but in the, well, I think that it's really going in the inflection point philosophy. So language approximations are okay, that's a delusion. As you can see, these guys are in a demonstration and their sign is no to bad things. Okay, cool. I'm generally displeased with the current state of affairs. Well, that doesn't mean, but I know there's a joke. But you know, when you write an email, not code, you know that it could be really hard if you want to be precise, if you really care about the words. It's not the same thing that the staff, or no, you want to be precise. And sometimes you do it because you know that there is going to be a lot of people reading that email. So I think, now, well, in most of the system, our code is like an email that's going to be read by thousands of people in the future. If it's not thousands of people, it is going to be thousands of times for the same small amount of people. So the idea is that we should really care about the language and not doing this kind of approximation. Well, it's more or less, it's okay. No, let's move the word in the writer and not in the readers. It's going to be solely a single time that you're going to write the code, and it's going to be 1,000 times that you're going to read it in the future. So there are different ways that you can try to design in a way that the language approximation are not okay. Sometimes it's, well, trying to design your system around bounded context. This is a core DDD concept. And the point is that, well, what I'm saying here is that within mapping or with another techniques, it's cool for identifying the different bounded context that your system has. So I can provide an example. Let's say that the outcome of that meeting of you is that you have a service that is called media, right? But it has, well, kind of a defined concept that it doesn't have anything to do with profiles, right? So it's quite obvious that happened. And in the future, then you refine your domain, and then you decide that media is holding, I don't know, license concerns and video concerns and other stuff, right? So the point is that even if I say that we should care about not using language approximation, you shouldn't, again, do it in the beginning, because otherwise you're going to get into not microservices but nanoservices. You're going to get into something that is too isolated, too fine-grained. So you want to find that sweet spot and then refine it in the future. For language approximation as well, this is, well, I don't know if you know the hexagonal architecture. For me, is one of the coolest way of explaining how a typical web application works. So the idea is that, okay, you have in here your external systems, and then you have inside your domain. So in here is where you really care about the language. This is something that this language is going to be served by you and by business. So you won't really care about it. And then you're going to have different adapters that are delivery mechanisms that are going to be working with HTTP, with web services, whatever. And in here, the language, I don't want to say that I don't care the language in here, but I want to say that maybe it could be different. What I don't want is that you have some technical language, like for instance, including API, well, Hibernate or whatever adapter language that you have. It's not really cool if you put it in here, because you are polluting your language that is served with the business. You can't serve with business, I don't know, transactional work. What it means transactional for a business guy. So it's not only that the language approximation are not okay, it's as well that you need to have different languages for different concerns. So try to keep your domain free of technical language. So yeah, language approximation are okay. Often I think that our profession is closer to literature than maths. It's not that the maths are not important, it's just that if you don't really care about language, quite likely that you're going to fail. So, business needs are stable. Well, that's an example that nothing is stable. This is George Clooney when he was a child. You can see. The stuff can change a lot. You never know what is going to happen. And the point of Agile, kind of the point is fighting against this kind of naive thought. No? Like, what business thinks that is going to happen is what will happen in a year. No, you never know. I mean, business is going to refine in this kind, at least doing software. I don't know doing hardware, but doing software, the stuff is changing a lot. So, what I'm going to show is a design strategy, a design architecture that is going to help you to follow, well, to fight against this kind of delusions, or the business needs are stable. And it's called CQRS. I don't know how many of you know the CQRS stuff, but it's called Common Query Responsibility Segregation. So that's really, really cool in order to fight against this business needs are stable delusion. I'm going to explain briefly. So instead of having a single monolith, the idea of CQRS is splitting your concerns between your commands and your query, right? It's important to know that this is an example that is using event sourcing, that is using different deployable units, but it's not really needed for following CQRS. You could do it everything in memory, everything in a single deployable unit. But for the sake of the explanation, for me it's easier to understand it when there are deployable limits as well, boundaries. So the example is like, let's say that a user, well, this is Twitter, let's say. Let's say that a user issues a command called create a tweet, and then you have your right side of your application, that is a command handler or whatever you want to call it, and this guy is going to store an event. So this is an action, I want to create a tweet, and this is an event. This is, okay, a tweet was created. That means that in here I can have a lot of validation, I can have a lot of enrichment, I can have the business logic of my application to create an event that is going to be here and it's not going to change. I mean, it's one of the rules of security is that you never update or delete your event store, right? So whenever this happens, that happens. And then it came the magic of CQRS and why it's cool for the business needs are stable. Then you can have as many as you want view materializers in here. What is a view materializer? A view materializer is some component or whatever, some class, that is going to this event store and is going to create different projections, different, if you want to say, different reports of your data. So that means that, let's say that this is like the first version of Twitter, and business only think that we're going to use timelines, right? So then you can create a view materializer that is going to grab guys in here, and it's going to create some view in whatever the normalized data store that you have. Then the read side is going to do a really, really simple get into that data store. That means that in 6 months in the future, business suddenly introduce the concept of hashtags, for instance, and the search for hashtags, obviously. You could have another view materializer in here that is going to grab the events that are in here, and it's going to say, okay, well, whatever events that are include a hash, okay, let's put it into another view store that is not a normalized MongoDB, but Elasticsearch, because business wants to search into that data store. So that means that CQRS is extremely, extremely good for fighting against this naive thought that the business needs are stable. Anyway, as I've been working with this, I could say that don't do it unless you need an extremely performant system. Because, okay, CQRS is following this. It's amazing. And, as the system could be deployable in different places, and you could have something like a completely uncoupled and really scalable event storing here, this is going to scale as hell. It's really cool for scaling. But this is going to add a lot of overhead, like whatever microservices that you have. So my advice is that, okay, if you want to do this, because it's the business, you should have in mind that it could be an overkill for your system. But as well, and that's just the last note in CQRS, is going to really, really help you in thinking in how your monolith is built. So there is a really, really long video of Greg Young, that is the guy that created this, it's like 6-hour video. But it helps you a lot to understand how the systems in the end are pretty much commands and query, at least our web application. And how this is a way of structuring the stuff, but even if you don't follow this, you should think in your system in commands and queries. And if you can, you shouldn't mix the concerns of those. Otherwise, it's going to be really complicated. So, business needs are stable. Well, that's not true. So, design with that in mind. Thank you. Any questions? Well, it's 35 minutes, so we have time if someone wants to ask something. If not, we can go have lunch.
I have one comment. It's when you said like what does transaction mean to a business person? I think that in more complex domains, transactionality is actually a business concern.
Mm-hmm.
Because like defining the boundaries of your transactions, you can only define the boundaries of your transactions properly if you understand how the business works, what needs to be rolled back, or what needs to be done as a unit or separate. So you cannot define the boundaries on a technical level. And I think that, like the rules prescribe, they talk about logging, and you had very valid points in terms of making some of the non-functional requirements as part of your solution. I think the transaction analysis is another one. It should be a core domain as part of your domain. Your system should have a place. Although it's a technical thing, but I think that it should be designed as part of your domain.
Maybe it was a bad example. What I'm trying to say is that the word transactionality maybe doesn't mean anything to business. Maybe business say unit of work, or maybe they say, I don't know, boundaries. And the problem is, and I know that you agree, when your framework or library forces you to use some words. Let's say that you use Hibernate or whatever, and it forces you, or Spring, it forces you to use the word transactional in your. Maybe the business don't want to use that word. But I agree that transaction. I mean, if you use, the concept of aggregate in DDD is completely inside of your domain, and the concept of aggregate, that in the end, I think that the only concept that is useful inside of an aggregate is the transactionality. So I agree that the concept of transactions should be inside of your core. But what I'm trying to say is that not exactly the word. So what I don't like is that my libraries or my framework dictate the word that I have to use on my domain.
I'm not very familiar with CQRS, but also I'm sorry I didn't join from the beginning of the talk.
Uh-huh.
You mentioned that there's an event store,
and
that there's some events going to the reviews area.
Yeah.
Is event sourcing part of CQRS? It's something similar, but it's not the same depending on the approach.
For me, well, the answer is no. I mean, it's not the same. But my experience is always doing the stuff together. And to be honest, I wouldn't recommend going with another approach. Why? Because I saw implementation of CQRS, everything in memory, and it gets a little bit messy. It's hard to understand. But if you have this completely isolated in different deployables and with an event source in the middle, it makes a lot of sense. So I would say that it's not needed, but I would recommend it. Because as well, something really cool about having an event sourcing here is that this CQRS that I show you here is just it could be just a single bounded context. So as I told you before, we have media, we have profiles, right, like different bounded contexts, and you could design your media component like this, and then you could do exactly the same with profiles, right? But what is really cool of having event sourcing is that media and profiles now, they don't need to talk through HTTP. They could communicate through the event store. And that's extremely performant, that's extremely uncoupled, and well, that's one of the benefits of having that. But no, you don't need to do it if you want. In fact, this implementation that I show you here is kind of the stuff that the Greg Young suggests in the video. But there are people doing different stuff. There are people that they are doing kind of command sourcing instead of event sourcing. So instead of, because the difference between command and event is kind of blurry, but it's important. Because a command is what the user says. It's, I want to create a tweet. An event is what you want to allow in your system to happen. So the stuff that we talked before about the aggregates should happen here. You should have your transactional boundary. You should have your rules in here. You don't want to put an event that is poison. You don't want to put something that is going to fuck up your systems. So there are people, because, well, I saw that implementation as well, but what they are doing is grabbing this create a tweet, converted it directly in a created tweet, and put it directly in an event. So it's not event sourcing, it's command sourcing. And that has the problem that then, this is your single source of truth, that is a single source of truth that it could be, well, fuck up, yeah, full of shit or whatever. So
another cool thing
yeah.
of the event sourcing could be that if one event is failing, you can do a fix for this bug, and you can repeat the event that failed before.
Yeah, so that's, that's really cool. So one of the, let's say that, remember the second example I put, that you want to search by hashtags. This is going to be Elasticsearch. I don't know if you know Elasticsearch, the technology is quite cool, but it has a problem that it seems that it's quite easy to get corrupted data in here. So what you want to be able is to repump the data that is doing the data store, like the backup of this Elasticsearch, and you want to be able to replay the events and put it in here whenever you want. And the technology that are used for event storing, like Kafka or whatever, is quite easy to do that. Because what you do is you could have different consumers for this Kafka event, Kafka engine, and then you're going to have different offsets. Now, an offset is like a pointer, and where are you in the stack of events. So that means that you could keep those offsets, those pointers in another data store, and whenever you want to replay the events, you just go there, oh, okay, I'm going to replay not from the beginning of time, I'm going to replay from here, and it's quite easy to get another view whenever you want. Anything else? Okay, if you want to use the pictures anytime, I will share in Twitter. There are ones that are really cool. I would say this is the best one. This is cool as well. So, yeah, well, thank you very much.
Thank you.
First, what is diagnosis? Well, diagnosis is what you have to do when your tests are not enough. We are a software craftsmanship community, so we believe in tested code, but we are humans as well, so sometimes the tests are just simply not enough. Whenever that happens, what you need to do is go into your system and query the state of it to see what is the data that it puts your system in a buggy condition. So we have different methodologies to do that diagnosis. The most typical that we do is debugging, querying the data store that our application has, or logging. That's quite easy if you do it in a non-cluster synchronous monolith with a single data store. So I'm going to explain it. Well, how could you probably do it? So let's say that you have a single application server that is not clustered, it's only a single monolith and is going into, let's say, Oracle, something simple. So how do you debug this? Well, if you have a IntelliJ or whatever debugger that you are using, is Twitter, Felipe Fernandez. So let's start defining what is delusion. So this is the Wikipedia definition, a little bit complicated, but the summary is what is involved. It's a belief that is contradicted by reality, and as well it's a symptom of mental disorder. Maybe a little bit strong. I don't want to talk about that. I want to talk about mental disorder. But I like that word because well, as well because it's used in pop culture. I don't know if you know, there's a book called Delusion by Richard Dawkins, and it's trying to show how some kind of beliefs that are based on incomplete information or are based in simply not having good faith are really dangerous for whatever you are doing. So I'm gonna try to show different delusions in our industry and showing how painful and poison are for us. So yes, I told you I'm gonna go through a couple of delusions. But the blocks of those delusions are going to be pretty much operations, testing, and design. Let's start with operations. Well, first, I want to say that I want to talk operations from a developer perspective. I'm a developer. I'm not a sysadmin, but I'm going to talk not how to keep our system up and running, but what is the infrastructure that developers we have to create in order to keep those systems up and ready. I don't know how many of you are working in this kind of DevOps environment, but I would say that even if you don't or you are not interested because it's not related with your development, I would say this is something that is coming to stay because modern world with math and web services and stuff like this is forcing us to go into that direction. So, well, what I'm trying to say is that if you are not interested, try to listen because it's quite cool. So, first one, I'll have a look whenever it's needed. That's the first delusion. As you can see, this little girl is trying to embrace that attitude. No? So,
Are you going to use the flip chart?
yeah. I don't know where to put it. I was thinking to put it.
No, that's okay. No, I can't.
No,
That's
probably.
totally fine.
Cool. So, I'm going to talk today about DDD, but not the real DDD, about Delusion Driven Development, and why you shouldn't do it. First, I'm going to introduce myself briefly. Well, I'm Felipe Fernandez. I work at Software Craftsmanship for Codurance, for those guys. As well, Pedro is working with us. I'm currently working in a client called Crowdmix, really cool place. We didn't release yet, but try to remember the name. I think it's going to be something really big. I sometimes blog in the Codurance blog, so you can read the stuff there. And less often, I write some stuff in my handle, jump, and wherever I go to the floor, I will think on it. So, my diagnosis of why we do that, why we think this kind of delusion is, or because we are overconfident in our skills, or just because we are lazy. It could be a mix of both. It's just easy to think in the happy path scenarios. We are usually overwhelmed by the pressure of business. We have to deliver features, and then, well, let's think only on the happy path scenarios. The problem of that is that I think that most of us know that the cost of addressing those problems in the future are quite high. So I'm going to provide an example of this kind of I'll have a look whenever it's needed. That is diagnosis in distributed environments. I'm going to close the door. Yeah. Like that. So, diagnosis in distributed environments.